In the last lesson, we learned how to find the midpoint of a segment that was graphed on the coordinate plane. Now we're going to figure out how to calculate the distance between 2 points, or the length of that segment in the coordinate plane. So what if I want to find the distance between points G and H, which is the same thing as saying find the length of segment GH. So how am I going to do this? So we're actually going to set it up kind of the same way we did midpoint. If I'm traveling from G to H and I can only follow on the grid lines, how would I go? Well, I would go over a certain number and then I would go up. And notice that makes a right angle, so we have a right triangle. Now, I could have gone up first and then over, but it doesn't matter, it's going to be the same exact size triangle. So, what I want to do is count how long is that? How many units did I go? So, from G, this would be 1, 2, 3, 4, 5, 6, 7, 8 units long that way. And then how many up? That would be 1, 2, 3, 4, 5, 6. 6 units up. So there's a theorem in geometry, and you've probably heard of this before. I'm sure it came up in other previous math classes. But a very, very important theorem called the Pythagorean theorem, named after a Greek mathematician many, 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 many years ago. And he discovered that in a right triangle, the two sides that make the right angle, so the two red sides in my picture, when I add those together, so 8 squared, well actually let me write the general, let's do the general Pythagorean theorem. It says if you have a right triangle and you label the two sides that are perpendicular as A and B, and then the side that's across from the right angle, which is the longest side, as C, the relationship is that A to the second power plus B to the second power will always equal C to the second power. And so if you know 2 of the 3 sides, we can write an equation and solve for the missing side. And so that's exactly what we're going to do here. So we know that, and it doesn't matter if you want to call A 8 or 6, and then B would be the other one. So it doesn't really matter. So I'm going to have, let's say, 6 to the second power plus 8 to the second power equals C to the second power. Now, what is 6 to the second power? Remember, that means 6 times 6, not 6 times 2. So 6 times 6 is 36. And then 8 times 8 is 64. And that equals C squared, or C to the second power. And then I'm going to add 36 and 64, and I get 100. Now, that equals C squared. So what that really says is what number multiplied by itself is going to equal 100. Now, you can probably look at that and think, oh, that's pretty easy. That's 10. But what if you didn't know what it equaled? What if it equaled 97, let's say? Then there's not a nice number that you would have the answer for. So what we do is we take the square root of both sides to undo the square, and the positive root of 100 is 10, and the square root of C squared, since C is a positive number, it's a length, that just equals C. So this tells me that my missing side length in this triangle is 10, and so that's the distance between points G and H. There's no units on this problem, so it's just 10. Now, that's how you do it geometrically. There's also, just like we had a midpoint formula where you don't even have to use a graph, we have a distance formula. And so if we want to find the distance between 2 points, and let's call those points, well, let's label them just like we did before. Let's say the first point we're going to call x sub 1, y sub 1. And the second point is we're going to call that x sub 2, comma, y sub 2. Okay, it makes a nice pattern. Then to find the distance between those points, it's going to equal the square root, gigantic square root, and then we're going to subtract the x numbers. So that would be these, the x coordinates of our 2 points. So we're going to subtract those, and it doesn't matter the order. So I'll say x sub 1 minus x sub 2, close the parenthesis and square it, plus, and then we're going to do the same thing with the y coordinates. We're going to subtract those. So y sub 1 minus y sub 2, and then square that. And then we'll take the square root of that entire answer. So let's go back up to this problem and show you how to do that algebraically with this distance formula instead of doing it geometrically with the Pythagorean theorem. So let's label these points. So first of all, G is negative 1, 2, 3, 4, 5, 6 is negative 7, comma 2. And H has coordinates 1, comma 8. So now using those, let's go back and grab these circles. Those will be useful. All right, so now let's find the distance formula. So the distance from G to H, which we write as just G and H, equals gigantic square root, parenthesis, subtract the x numbers, negative 7 minus 1 to the second power, plus, and now we're going to subtract the y coordinates. Oops. So that would be a 2 and an 8. So 2 minus 8. And the order doesn't matter because we're squaring them. And now we'll go ahead and simplify this. And remember, order of operations, we're going to do in the parentheses first. So we're going to have square root. Negative 7 minus 1 is negative 8 to the second power. 2 minus 8 is negative 6 to the second power. Let's put that back. Kind of running out of room here. And so let me keep going to the right. Now, negative 8 squared, that's negative 8 times negative 8, which is going to be a positive 64. And then a negative 6 squared, negative 6 times negative 6 is a positive 36. And so when I add those together, I get 100. Wait a minute, that's exactly what I had when I did it with the Pythagorean theorem. The square root of 100 is 10. And that's the same answer. Well, it turns out this distance formula actually comes from the Pythagorean theorem. So they're really related. So if you have a picture with a segment, I would probably do it with the Pythagorean theorem. And it's probably going to be a little quicker. If, on the other hand, you don't have a graph and you just have the coordinates of 2 points, instead of getting a graph, plotting the points, connecting them, and then doing the Pythagorean theorem, it might be easier to do the distance formula. So it kind of depends on the problem, and it also depends on which way you would rather do. Now, the notation, as I mentioned, for the distance between 2 points is just the 2 letters. The order doesn't matter, but there's nothing above them. When you have 2 letters with the segment above, that means the segment GH. And so a problem could either say, what's the length of the segment GH? Or it could just give you the 2 letters and say, what is GH? They mean the same thing. We're finding the length of the segment or the distance between the 2 points. Okay, so let's try one more. And you might want to hit pause and try it and then compare your answer. Okay, so here's my 2 points. Maybe this will help. I'll label them x sub 1, y sub 1, and x sub 2, y sub 2. And then the length of AB, so AB equals big square root, subtract the x numbers. 7 minus 2 to the second power plus, now subtract the y numbers. Careful here, negative 4 minus, and the next y number is a negative 8 to the second power. And away we go. Now, you have a calculator. If you have a calculator or use a calculator on your iPad and it has parentheses, you can just punch all of this in at once and get your answer and be done. So when I punch this in, I'm going to get 7 minus 2 is 5, and then I'll do that to the second power. Negative 4 minus a negative 8 winds up being a positive 4 to the second power. Now 5 squared is 25. 4 squared is 16. When I add those together, I get 41. Uh-oh. That's not one of those nice perfect square numbers. So I know this is going to give me a decimal. It's going to give me something a little more than 6. Because the square root of 36 is 6, and the square root of 49 is 7, and 41 is between those, so it's going to be something in between 6 and 7. But I'll have to use a calculator to get at least a decimal approximation for that. So let's call up my calculator. And I'm going to look for the square root button. I have to press second and the x squared button. That gives me square root. And then I type in 41 and press enter. So if I round to, let's say, 2 decimals, that would be 6.40. The third decimal is a 3. So let me write that, 6.403. So approximately equal, blah, 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 blah. If I want you to round to 2 decimals, that means we're going to cut it off here, and then I look at the number right after that. If it's 5 or bigger, I bump this number up by 1. If it's less than 5, I don't bump it up. So in this case, I'm not going to bump it up. And there's my answer. If I wanted the exact answer, I would just leave it as the square root of 41. All right, now let me show you one more thing. As I mentioned on the calculator, let's back up. Once you plug in right here, once you plug in the numbers for the distance formula, before you do any of this simplifying work, you can grab your calculator and just work with that. And I'll show you what I mean. So I'm going to do second x squared. So I got my square root. And now some calculators will automatically put a parenthesis inside the square root. If that's the case with the one you're using, you're going to need to put a second parenthesis. So just be aware of that. So anyhow, I have a parenthesis, and I'm going to type in 7 minus 2, close that parenthesis, and hit the x squared button, plus, now another open parenthesis, negative 4, there's a different button usually for the negative. It's a smaller negative. Mine's down at the bottom. Negative 4 minus, and then a negative 8, close parentheses, hit the x squared button. Now if you see, that's exactly what I wrote down to start my distance formula. So I just punched it all in on the calculator in one step, press enter, and boom, I'm done. So if you're having trouble and you're making mistakes as you simplify what's inside the square root, then maybe try using a calculator to just punch it all in at once. All right, your assignment is worksheet 16 and only the first side, so numbers 1 through 12. You've got graphs for the first few problems. I'd probably use Pythagorean. I want you to actually use Pythagorean theorem for that. And then for the ones below, which only have the coordinates and no graph, I'd like you to use the distance formula. So you should practice using both. And on a quiz or a test, most of the time I'll let you take the option of how you want to do it.